our Unit 4 quiz from yesterday, and we're going to go through and figure out what y'all did not understand. Okay, so I'm going to copy these over into the smartboard so I can write on them. So give me one sec to copy. All right, so I'm going to start here with number 1. Okay, so number 1 gave us a triangle ABC, and it says that the measure of angle A is x plus 10, and the measure of angle B is 2x minus 15, and the measure of angle C is 4x minus 25. What is the measure of angle C? Now, the picture was given so that you could mark this up if a visual helps you. You do not need a picture to solve this problem, because how many angles are in every triangle? 3. And what do those 3 angles always add up to? 180. That's what you needed to know for this problem. You have 3 angles, A, B, C, and they tell you what those 3 angles are. We know that if we add those 3 together, it should equal 180. Now, if you wanted to go in your picture and label it to help you see it better, you could do that. Okay, but really all we needed here was to know the triangle angle sum theorem, which is that the 3 angles of a triangle add to 180. So some of you may write it out like this as your first step. Some of you may just come up in the problem up there where it's already written, and you would count your x's. You'd say, okay, there's 1x, okay, 2 more, that's 3, 4 more, that's 7. So some of you may jump to this step where you're writing 7x, okay, but that's just combining like terms from that previous line. So if you wrote that first line, great. Now we're combining like terms, okay? And then some of you may say, okay, I've got positive 10 minus 15 minus 25. And you may do it from up there. Some of you may do it down here. Either way, you're doing the same thing. You're combining like terms. So what do you end up with? Minus 30, negative 30. And what does that still equal? What's still on the right side of the equation? 180. That has not changed. But now we have simplified the left side so that we can solve for x. So what am I going to do to get x by itself? Okay, now what do I do to get rid of the 7? And what did you get? What's 21 divided by 7? 3. So 210 divided by 7 is 30. You don't have to do that in your head. You have a calculator. So is the answer B? No, the question didn't ask for X. If you chose B, good job on getting this far, but you didn't read carefully. You didn't go back and read what they are asking for, which I tell y'all all the time, go back and double check, is that what they're asking? They are not asking for X, they are asking for the measure of angle C, which is 4x minus 25. So now I have to plug that 30 in place of x. So we got x is 30, and I plug it in, and I calculate this. And again, you don't have to do this in in your head. You have a calculator that'll work for you. So you're multiplying 4 times 30 minus 25, and you get 95. So the measure of angle C is 95 degrees. Now, I don't know if that's C on y'all's, the answer choices may jumble for everybody. So don't just say A, B, C, D. Actually give the number answer, because it may be in a different order on yours. Does this one make sense? Okay, just out of curiosity, how many of y'all had picked 30? Okay. Go back and read and make sure you're answering the question asked. Now, I have shown y'all how to do this algebraically all unit, and we practiced it. We did it in the notes. We practiced it in the practice. You were supposed to do it on the quiz. If you've done this on the review, this is how I've showed you how to do it. But I want to show you something, because you get to use Desmos. I'm going to pull up a Desmos graphing calculator here, and let me split screen this. If you know how to set up the equation, y'all can type an equation in Desmos. Do you know that? So you could type in that really long one, or you could type in what you got here, 7x minus 30 equals 180. Oops, I didn't get an equal sign. Let me get an equal. Okay, so 7x minus 30 equals 180. And it will graph a line at your solution. My solution, see, here it is. And I can see that it's at 30. So x is 30. And it would save you from having to do this solving for x. Okay, I could type it in without having combined like terms. I could type in x plus 10 plus 2x minus 15 plus 4x minus 25 equals 180, and see how it still shows the solution is 30? So this part you can do in Desmos by looking at now when you're looking at the graph, you're looking for, when you type in an equation, all you're going to get is a vertical line like this crossing the x-axis, and where it crosses the x-axis, that's what x equals. That's the solution. Do y'all follow that? Okay. So, and I'm sure your algebra teacher showed this to you last year, but if you didn't remember it, or maybe somebody didn't show it to you, I just showed it to you. So you can save some time with your equations, or if you are struggling on this step, if you keep messing up solving for x, let Desmos tell you the answer there. Now you have to know those are supposed to add to 180, and you have to know now that I have x, I need to plug it back in. So you still have some work to do, right? But it will do that solving for x portion for you. Feel okay about that one? Yeah? Okay. Look at number 2. So this one looked kind of maybe overwhelming or intimidating at first because it's kind of a lot. It's that table where you had a lot of blanks. But it's simply asking us to use, again, the triangle angle sum theorem, the sum of the interior angles of a triangle. What do the sum of the interior angles of a triangle always add to? 180. That's what they're asking us to use. They're saying use the fact that the 3 angles add to 180 to find the third angle. So in the first triangle, they give us 2 of the angles and they're looking for the third. So if you know 2 angles, how do you find the third? You can do 180 minus 60, or you could add these first and then subtract from 180, however you prefer to do it. Okay, but the sum of the interior angles of a triangle is 180. So we're simply going to say, so do y'all prefer to add the 2 that you know first, or just do all subtraction? Okay, so for this one, I'm going to do 180 minus 60, and that's going to leave me with 60. Now, how about that? Now we've got 3 angles that are all the same, 60, 60, 60. What type of triangle is that? If all 3 angles are the same, that means all 3 sides are going to be the same. What does that mean? What's the name of a triangle where all 3 sides are the same, all 3 angles are the same? What's a word for the same? Equal. Look at those words up there. Which one has equal in it? Equilateral. Okay, if everything's equal, you have an equilateral. Now, equilateral is referring to the side length, so it's classifying by the sides. I would say equilateral. Now, what size are all three of these angles? Because if we're classifying by angle, we're talking about the size of the angles. Are they acute, obtuse, or right? What is a right angle? A right angle is 90 degrees. Are any of these 90? No. What are all of them? Acute. 60 is less than 90. Acute is less than 90. If all of the angles are less than 90, you have an acute triangle. Okay, now we're going to do the same thing for this next one. I know that the sum is 180, and I'm going to take away 110 and take away 35. And what does it leave me with? 35. So that third angle should have been 35 degrees. So that one's there. Now, look at these. What do you notice about these three angles for classifying purposes? Two of them are the same. What's that word? What term when two of them are the same? Two sides are the same, two angles are the same. All right, so this is a vocab issue. If y'all don't know your vocabulary, you 4.1 was your notes where we did all the vocabulary. Some of you need to go back and study your vocabulary, make flashcards. When two are the same, okay, that's an isosceles triangle. When two sides are the same, and two sides are the same since two angles are the same. We know that. Now, the angle sizes, look at the size of these angles. What 35 is acute, but what's 110? Yeah, that's bigger than 90. That's obtuse. Okay, and then last but not least, I immediately see a 90. So what type of triangle is this? It's a right triangle, because you have a right angle. And the only one left, I mean, I'm going to find the missing angle, but what's the only word left over here? And does anybody remember what scalene means? It means all of the sides are different, or all of the angles are different. Now, if I go to calculate here, 180 minus the 90 minus the 42, what am I left with? So this angle should have been 48 degrees, which was that one. Okay, and those are all different, aren't they? 42, 48, and 90. They're all different, so that's scalene. If y'all aren't able to classify your triangles, you need to go, because you don't know what the vocabulary is, you need to go back and study the vocabulary. Make some flashcards or something. All right, let's look at the next one. Okay, number 3. Says, given the following triangle, determine the value of x. What do these arcs on the triangle mean?
They're the same.
They're the same. So what type of triangle is this one? What did we just talk about if two are the same? All three is equilateral, but if just two are the same, we said it's isosceles. Isosceles. This is an isosceles triangle because those two base angles here are the same. Now, if the two base angles are the same, that means that two of the sides are the same, which are the ones that correspond to those angles. So that means that 8x minus 29 and 11, those two sides, are equal to each other. So I'm going to set them equal. And now it's an algebra problem. But what shortcut did I just show y'all for solving the algebra part? Desmos. Okay, so I could come over here in Desmos. Why is Desmos not opening? And I could come and plug that in. What is it? 8x what? And so what's my solution? 5. Done. X is 5. Everybody understand how I did that? Okay, so I use Desmos and I get, oops. I put use Desmos.
You know I'm gonna plug it in.
And I get X is 5. This one, I go back and read. I always go back and read. Determine the value of X. That's all they asked for. So we're done. We don't have to go back and plug it in because they asked for X. They did not ask for this. If they asked for side PR, I wouldn't have had to do anything. I would have said PR is 11 because it's congruent to RQ, right? Do y'all understand that? If they ask for this side length, it's 11 because this side's 11 and they're congruent.
What did they ask for 1?
If this was not just a number, if this was also an expression, it had an X in it, you would set those two equals, solve for X, and then yes, you would have to plug the X back in. But since this one has a length, a measure, there's no X in it, you already know the side length. All right, let's look at the next one. Number 4, if you missed number 4, this one is about triangle mid segments. This was, I want to say 4.4. No, it was 4.5. So we did triangle mid segments in 4.5. If you need to go back and look at your notes, we said that a mid segment is parallel to one of the sides of the triangle and that it's half the length of that side of the triangle that it's parallel to. Let me finish. I copied the picture. Let me copy the question here. Okay, so the question is, if this is our triangle, and it tells us that these are midpoints, FEG, this blue triangle in the middle, is formed by connecting midpoints. So F, E, and G, all those red points are midpoints. That's what this says. Okay, so those are midpoints. So that means that these blue lines are mid segments. And we said that a mid segment is parallel to one of the sides. So this side is parallel to this mid segment. Do you agree? Don't see that? So that EG, that mid segment, is half the length of that side. So if that side is 20, what is the length of EG? No, half the side is 20. So the mid length, the mid segment length is 10. Yes, it's half. You divide by 2. Now going in reverse, let's look at it this way. This one, they gave you the mid segment. Oh, that's supposed to be highlighter. Why are you not highlighting? Is 5. And so look at the side that it's parallel to. What would it be? 10. Yeah, this time you're doubling because you're going from the short one to the long one instead of the long one to the short one. So here we went 20 divided by 2 is 10. Now we're going 5 times 2 is 10. So this length is 10. Okay, now last but not least, we need FE, which is parallel to LK, and LK is 14. And so what would this mid-segment FE be?
7.
Okay, so make sure you plug them in there. FE is 7. EG was 10. And stop working for a sec. And then that was JK was also 10. Okay, do we understand the relationship between a mid-segment and the side that it's parallel to? Okay, that's 4.5 notes if you need to go back and review that, study that. Okay, let's look at number 5. Number 5 was a more complex. It has some overlapping segments, creating 3 triangles in this picture. So you have to work your way around this. Doing that leaf assignment that we did, where it was all overlapping and stuff, and you had to work your way around, that should have been pretty good practice for this, because it's like, what are all of these different relationships that we've learned about? Okay, so I'm going to start. It doesn't actually, I can start from the left or the right. It doesn't matter. We know that the 3 angles of a triangle add to what?
180.
So in this triangle on the right, all 3 of these should add to 180, and I've used 61 and 42. So I can figure out what's left for that 3rd angle. Do y'all agree? So that is 77. So this angle here is 77. Now, how does that angle compare to angle 1 and angle 4? What are the relationships that you see? 4 what? It's not corresponding. When they're across from each other at an intersection, those are vertical angles. And vertical angles are congruent. So what is angle 4? 77. So angle 4 is 77. Okay. Now, I can't find 2 or 3 from this way, so I'm going to have to work my way back over here. But I can find 1 right now. How does 1 relate to the 77-degree angles? What is happening? What is this? A line, right? How many degrees in a line? 180. So the angle 1 and the 77 should add to 180, shouldn't they? So I can do 180 minus 77 to see what's left. So that's 103. So angle 1 should be 103. All right, now I have to come over here to the left side because I can't get 2 or 3 from what I have here. Okay, but that same concept of a linear pair, they form a line together. This is another line, isn't it? So could I work my way into the triangle from that 133? What would I do? Yeah, 180 minus 133. And I am left with 47. So this angle in here is 47 degrees. Now, I said that the 3 angles in the triangle have to add to 180. So I can say 180 minus 58 minus 47 and see what's left for this 3rd angle is 75. And then what angle relationship does that 75-degree angle have to angle 2? Yeah, they're congruent. Those are vertical angles, just like the 77 and the 4 over here. Across from each other at an intersection. These are across from each other at an intersection. So angle 2 is 75. All right, now last but not least, how can I find angle 3? Yeah, because I have the 2 angles of this bottom triangle, 75 and 77, and I know that the 3 angles have to add to 180. So 180 minus 75 minus 77 to see what's left. And it's 28. Okay, so what we had to know for this was triangle sum theorem. The 3 angles add to 180. I had to use that in all 3 of these. But I also had to remember some past angle relationships. I had to remember a linear pair is supplementary. They add to 180 if they form a line together. And I had to remember vertical angles. Angles across from each other at an intersection are congruent. You feel okay about that one? Okay. Let's look at number 6 then. Number 6 was a vocab question. So number 6 is what you needed to know on number 2. The types of triangles. Classifying triangles. So a triangle with 2 sides that are equal. What did we say? If 2 of the sides are equal, it's isosceles. I'm just going to color code or draw lines. On yours, you're going to have to write words because you don't have this image on your thing. But you could just write isosceles has 2 sides that are equal, or 2 equal sides is isosceles, however you want to word that. Okay, a triangle with one angle that's exactly 90 degrees. What's a 90-degree angle? A right angle. So a triangle that has a right angle is a right triangle. A triangle with no equal sides. They're all different. What did we say that was earlier?
Scalene.
Scalene, very good. A triangle that has one interior angle that measures more than 90 degrees. What type of angle is more than 90 degrees? Obtuse. So an obtuse angle in a triangle makes the triangle obtuse. Okay, a triangle with 3 congruent sides. All 3 sides are the same. Good. All right, and then last but not least, there's only one left, but if all of the angles are less than 90, less than 90 is an acute angle, and if they are all acute, then the triangle is acute. Yes. I'll give you all a sec because I know y'all actually have to write words on that one, so I'll leave that up there for a second. Freeze that while I copy over the next question. You all good, or you still need some time? All right, let's look at 7 then. Let me unfreeze that for you. Okay, so number 7, this one actually wasn't a triangle, but it could be a triangle. I could close in AB, right? And then I have a triangle. Okay, it doesn't matter if it's a triangle or not, but there is an angle here. It says ray OC, so that's this orange one, bisects angle OAB. Some of y'all are still struggling with naming your angles. Remember to trace in that order, AOB. So this is the angle down here that we're talking about. So this angle is bisected. What does bisect mean? Cut in half. Okay, so that means that's why they have the tick marks here. This is the same as this. They are cut exactly in half. They are equal to each other. Yes? So if they are equal to each other, that's what I'm going to write it out as. 5x plus 7 equals 10x minus 3. Now, I can solve this algebraically, and I think most of you can solve this algebraically, but what could you do to save some time? Let's put it in Desmos. 5x minus 7 equals 10x minus 3. What's the solution? Negative 0.8. Now, if you don't want it as a decimal, oh, I typed that in wrong. Look at that. That's a +7, isn't it? I wrote minus. That's my mistake. Now let's see, what's the solution? 2. So 5x plus 7 equals 10x minus 3. I get 2 for x. So again, I'm going to come over here and I'm going to put that I use Desmos. I got x equals 2. Now, go back and read the question. Did they ask for x? No, they asked for the measure of angle OAB, which is the one we highlighted. So I need this entire angle. So I'm going to take that x and I'm going to plug it in for the two smaller angles. So 5 times 2 is 10, plus 7 is 17. So I get 17 for this one. Now, what should I get for this one also? I should also get 17. I'm going to double check it because make sure that we solved correctly. But if I plug in my 2, 10 times 2 is 20, minus 3 is also 17. So that entire angle is what they're asking for would be what? What's 17 plus 17? Or 17 times 2, however you want to think of it. 34. So the whole thing is 34 degrees, which is what they're asking for. How many of y'all picked 17? How many of y'all picked 2? Because you're not going back and reading the question. They did not ask for x. If you're stopping when you solve for x, you're not answering the question. Okay, you're getting part of it right, and that's good. That's a good start, but you've got to read what they're asking for. All right, on number 8, which of the following lengths will form? This is the last thing we talked about in 4.6. This is that 4.6 notes was triangle inequality theorem and hinge theorem. This is triangle inequality. Will it form a triangle? What was the triangle inequality theorem? Who remembers? What has to be bigger?
The sides.
Which sides?
Like the sides of the triangle.
So there's 3 sides of a triangle, right? We have to take 2 of them. Which 2 are we going to look at?
First 2.
Not necessarily the first 2.
Oh, the smallest.
The 2 smallest. So what you need to know are the 2 smallest sides or shortest sides must add to be what? Bigger or greater than the largest side or the longest side. So the 2 smallest, I'm just going to circle in each of these sets, and I'm going to add those. So 3 and 12 would be 15. 5 and 6 would be 11. 4 and 7 would be 11. 10 and 10 would be 20. And 3 and 6 would be 9. Now I'm comparing it to that third side. And because this is what we did in our notes. We did this comparison and we want to know, is 15 greater than 20? No, it's less than. So that can't form a triangle. Is 11 greater than 7? Yes, that can form a triangle. Is 11 greater than 8? Yes, that can form a triangle. Is 20 greater than 18? Yes, 20 is greater than 18. Is 9 greater than 9? No, those are equal, so that cannot form a triangle. It has to be greater than. We're looking for greater than. So the purple, the sum has to be greater than the long side. Okay, that helps you work it out. Do y'all follow? Okay. All right, number 9. This is the hinge hinge theorem. This is the one I showed y'all. I explained it as the hinge of a door. When the door's opening and closing, the angle gets bigger when the door's opening, smaller when it's closing, right? And as the door closes, the distance between the edges gets smaller. So the smaller the angle, the shorter the side across from it. The larger the angle, the longer the side across from it. So when they ask us to order, we first of all need to read carefully, smallest to largest. So what is the smallest side here? 15. What angle is it across from? In. So angle in is the smallest angle. Okay, now I'm going to go to the middle. What's the middle side length? 19. And it's across from angle U. So angle U is in the middle. And then 33 is the longest side, and it's across from angle C. So angle C is the largest angle. So there's my angles ordered from smallest to largest. Good? And I think yours was like a drop-down menu you had to select. All right, last one. Number 10 says they want us to find, in this figure, AC is equal to CD. So that's the first thing I'm going to mark. AC is equal to CD. So AC is equal to CD. So this triangle at the bottom, this ACD, do y'all see that one? It's isosceles because they just told us those two were equal. Now it says the measure of angle EBC is 35. So E to B to C. If I go from E to B to C, that's this angle up here, isn't it? And then they tell us the measure of ACD. So if I go from A to C to D, that's this angle here, it's 124. So we're going to have to work our way around, kind of like that other one, and find this missing angle X down here. Now, in an isosceles triangle, I am focusing right now, you don't have to highlight this, but I am going to highlight, I'm focusing on this triangle. It's isosceles. If I know that vertex angle is 124, I do 180 minus 124. I'm left with 56. I know that these two angles have to be